How does a voice agent know when to stop and listen? Welcome to AI Agents in Depth, Episode 9, Multimodal and Real-Time Agents. In 7 minutes, you'll have a state machine that maps the pipeline, handles real-time interruptions, and runs offline. Last episode, your agent wrote its own tools. Today, it gains a voice, sound flowing in, sound flowing out. Start with the source. On the right, the book pane opens, a PDF viewer inside the editor, showing Chapter 9, before we build anything. Chapter 9 of Boji lies AI Agents in Depth. Section 9, 2 gives us the voice pipeline. Section 9, 3 gives us turn taking. Those are today's 2 anchors. A voice agent isn't one box, it's a chain. Let me draw the cascade end to end. Six nodes left to right. Microphone, VAD, speech-to-text, your agent, text-to-speech, speaker. VAD, voice activity detection. Fires discrete speech-started events, the pipeline's entry point. Read the arrows, speech segment, transcript, reply text, audio. Swap any one stage, the rest don't care. Delay stacks in series. Speech-to-text, 3 to 500 milliseconds. The model dominates, 1 to 3 seconds. Synthesis, 2 to 400. Round trip, 2 to 5 seconds. Your turn. Reopen the cascade diagram we just drew. 3 paradigms ride it. Turn-based, the one we build, and streaming, which overlaps stages to have the weight. The third, end-to-end, one model, audio in, audio out, like GPT-4o Voice or Gemini Live. Fast, but it locks every stage. Cascaded still wins where components must be best. Chapter 9, Section 9. 3 defines the turn-taking state machine. Let's see the whole thing at once. Three boxes. Listening means VAD's active. Thinking means LLM's computing. Speaking means TTS is playing. 4 arrows connect them. Each arrow is an event that fires a transition. Green arrows trace the normal turn. Speech detected, response ready, playback done. 2 red barge-in arrows cut straight back to listening. Streaming TTS doesn't remove this. Midstream cancellation is harder, not easier. Here's where barge-in comes from. Section 9. 3 of the book names these events. They are not invented here. Right here, Section 9. 3 names all 4. Speech detected, response ready, playback done, barge-in. The book's vocabulary. You'll use these exact terms in code. VAD fires the barge-in event automatically during playback. No button, you just talk. It cancels TTS and drops in-flight LLM tokens. Skip it, and the agent sounds like a phone tree IVR. Your turn, a quick throwaway demo, right in the terminal, before we write the real class. We define a temporary enum inline, just to see the behavior. String-based state names hide typos silently. Enum catches them at import. Watch. Listening is 1, thinking is 2, speaking is 3. We never use those integers. Identity is always the member name. A typo raises a name error at import. Caught immediately. 1 new import. We pull in enum and auto from Python built-in enum module. That is the entire diff. Composability means multimodality, is just a wrapper around the brain. Everything we need is already here. The conversation function, the LLM stub, the tools registry, all from EP01 to EP08. We just add the voice layer on top. String states let typos create silent bugs. A misspelling becomes a new state, never an error. Enum stops that cold. Three states, three lines. Auto, which comes from the enum module, assigns unique integers, but you will never use them directly. Identity is always the member name. Turn state. Listening, not a raw number or string. Here's the key insight. The conversation function from EP02 is the thinking step. No new agent needed. The state machine just coordinates. Conversation expects an iterable. We wrap the transcript in a list. The LLM parameter is injectable. Conversation knows nothing about states. Transitions live inside the machine. LLM replies arrive asynchronously in real stacks. The response ready callback fires when it's time to play. Then barge-in drops it. If you're already listening, barge-in returns silently, no error. Clearing the current response field models TTS cancel and LLM buffer drain. The machine never touches audio directly. Your turn, run this. Confirm the machine imports cleanly before we write any tests. Turn state, listening prints clean. No import errors. The state machine is live, and the conversation function inside, it hasn't changed one character. These two tests drive the state machine with pure Python method calls, no microphone needed. Here is the file. You will add two test functions at the very bottom, below the existing EP08 tests, calling state machine methods directly. That is exactly how production voice stacks do integration testing. The normal turn proves all four transitions in sequence. Start listening, talk, think, speak, return. 4 assertions, one after each transition. There are 3 states, but listening is checked twice. Once at the start, once at the end. The test calls 3 event methods directly. No microphone, no audio. Deterministic every run, just like EP01 through EP08. Barge-in is what separates a conversational agent from a phone tree IVR. Let's prove it resets cleanly. 2 assertions. State returns to listening and the current response field is none. That's the drop-in-flight contract from Section 9. 3. Offline. Your turn. Open the terminal and run the whole test. Sweet yourself with pytest. All green. This is the control logic, a real voice stack wraps. Swap the speech event for a real VAD callback, and you have a production voice agent. Your turn. Open agent. Pi and find the conversation function. Count the lines you changed. 0 lines of the conversation function changed. Multimodality wraps a brain. It doesn't replace it. Real production systems add buffering, error, and idle states on top of this. You mapped the 5-stage voice cascade from mic to speaker. That's section 9. 2 of the book, and learned latency stacks up across each stage. You built a TurnStateMachine using enum states: listening, thinking, and speaking. Barge-in snaps straight back to listening and clears the stored response. Section 9. 3. And the conversation function did the thinking step untouched. Multimodality is a wrapper, not a replacement. Pause here and try this. Add an error handler method to TurnStateMachine. Reset state to listening and clear the stored response. The same 2 moves barge-in makes, but triggered by a failed LLM call instead. Then write a pytest that drives the machine to thinking, calls that method, and asserts the state is back to listening. Quick check, which Python module gives you enum and auto? The enum module. Import enum and auto from it, and a typo in a state name becomes a name error at import time, not a silent runtime bug. Second question. When barge-in fires while the agent is speaking, what 2 things must happen? State resets to listening, and the stored response is cleared to none. That models TTS playback cancel and LLM token buffer drain in a real voice stack. Next up, Episode 10, Multi-Agent Collaboration. Follow so you don't miss it.